Thermohaline circulation, global phenomenon just like the World Cup. Thermohaline can be broken down into two words, thermo meaning temperature and haline meaning salinity. In the oceans, the cold dense water remains below the warm surface water. Wind blowing over the ocean drags the top layer of ocean, which influences the layer beneath. These layers above influence the layers below, and this can continue till around 400 meters. This gives rise to gyres. As we move towards the poles, the water becomes more saline because as ice freezes, those ice crystals trap water, leaving the salt behind, making the water more denser therby, more saline. Cold, dense water sinks, which is replaced by the warmer surface water. This vertical movement of water is called as thermohaline circulation. Whether a fluid parcel will float or sink depends on its buoyancy anomaly. Let's derive the buoyancy equation. Buoyancy equals to the minus g into sigma minus sigma naught divided by rho reference. Where g is the acceleration due to gravity, and sigma minus sigma naught is the difference between the density of the parcel and its surroundings. Buoyancy of seawater at the surface depends on both the T and S distribution. To determine whether convection will occur, we must therefore consider both the flux of heat and fresh water across the ocean surface, which induce T, S and hence buoyancy changes, as well as the ambient, pre-existing stratification of the water column. dt divided by dt equals minus 1 by rho reference Cw into delta Q by delta Z. S divided by dt equals S into delta epsilon by delta Z dash. SCW is the heat capacity of water, and Q and ER, respectively, the turbulent vertical flux of heat and fresh water driven by air-sea exchange, convection, ice formation, and vertical mixing in the ocean. The surface Q equals Q net, the net heat flux across the sea surface, and E equals S equals EP evaporation minus precipitation, including that due to river runoff and ice formation processes is the net fresh water flux across the sea surface. Typically Q and E decay with depth over the mixed layer from these surface values. Note that the minus sign in the very first equation ensures that if heat is lost from the ocean, Q net will be greater than zero, its temperature decreases. Buoyancy equation can be deduced by taking d by dt of very first equation. dB by dt equals minus g divided by rho reference into alpha a divided Cw into delta Q by delta Z plus rho reference beta S into S delta epsilon by delta Z, which can be written as minus delta B by delta Z dash. Where B is the vertical buoyancy flux. The surface is equal to g by rho reference into alpha r into Q net plus rho reference beta S into E minus P. This is an equation combining two components, the thermal and the haline. Units of buoyancy flux are meter square per second raised to 3, that of velocity into acceleration. See that the buoyancy flux is made up of both thermal and haline components. Global conveyor belt is made up of the surface currents and thermohaline circulation. Single drop of water may take 1,000 years to travel across all the world's ocean basins. In recent years, due to global warming causing heating of the sea water, this conveyor belt has slowed down even more. This belt brings up the nutrient-rich water, which has microorganisms which are critical as they form the basis of the food chain. There is a fear that if the global sea temperatures continue to rise, this conveyor belt might come to a stop. Life does not thrive in stagnancy.